So welcome to my next gen shoulder pads design by Henrik Nystrom. You may think, what's the big deal here? It's just like shoulder pads, but they are hot and they can reduce your performance because you're so hot. And they are the largest piece of equipment that you wear as a football player. So why not, try to make them better and cooler, especially since we've already done things with helmets before. So, why not, innovate in shoulder pads, which are a larger piece. And in a study called the American Football Uniform Uncompensable Heat Stress and Hypothermic Exhaustion, they had 10 people put on shoulder pads and helmets here. This is just like all the jerseys and stuff. They had them do different, exercise. So they have, lifting, they have walking, and you can see that, towards the end here, the shoulder pad group, dips out a lot faster than the other groups, and that really is something that, will affect the player. And you can imagine practice isn't just walking on a treadmill. It's a lot more intense than that. So in reality, you wind up hitting that wall a lot earlier, and it goes for several more hours after. Some practices go up to 3 hours. So it's something that really impacts players, which is why the University of Florida has actually tried to solve this already. They put some pipes in an ice chest and pumped compressed air through it and shot it down the shoulder pads, but it only works while you're on the sidelines. So that is an issue that, you can't have it when you're on that crucial third down on the field. So you would want to have something that you can use on the field. Which brings me to our new solution that we have, which is put phase change material. So this is a solid that then turns to a liquid in pads. So this would essentially act as like a buffer in shoulder pads, and it's something that's passive, always on. You don't need to charge it up, dump ice in it, anything like that. It's just integrated into the actual foam itself. So the new science is that you can put phase change materials, or PCM, into the foam and have its structural properties stay unchanged without it leaking out. Because like I said, it takes energy in, and then instead of heating up, it turns to a liquid first and then starts heating up. So it has like a buffer around 80 degrees, and it's contained in the foam lattice. It's not actually leaking out or any other type of containment. And why is this important? Well, because football has a very thin edge that people will do anything for, and every team wants to win, and any small thing will help. And this is something that will help out a lot of players, just a little bit, where teams would want this. So here's my budget. It takes about $4 worth of PCM to actually put into the rest of the shoulder pads. So it's not actually that much money extra into every shoulder pad produced for the amount that you can then charge, because premium shoulder pads go for $500–600. So that's a big markup you can have. And then I included, a test setup for 2 months of a team of 4 of engineers to work on it, with having, a bunch of different prototypes, as well as training for the new staff to work on the new machines or the new protocols, or however they make it. And these numbers are based off a quote I got from Microtech for the PCM supplies. The rest of the numbers are kind of estimates. If I dove into Rydell's actual budgets, we can kind of get a more accurate budget. Or once we do some testing, we can figure out what machines we need and stuff like that. But that is, something that we'd find out a little bit later. And so this is just kind of an initial, price estimate to kind of look at, how much does this technology cost. So what is our impact on this? It is to revitalize Rydell's shoulder pad offerings. They've been kind of stable for a while, and to not be complacent, to really have an impact and be the safest brand for the new generation, and really pull in customers for it. So that is why we should invest in these new shoulder pads. Thank you. And then for my sources,